Hello, class. I'm going to go over section 4.2 in your statistics workbook. It's called Addition Rules for Probability. Okay, so go to page 104 in your workbook, okay? All right, so it starts off with some definitions, mutually exclusive events. So these are two events are considered to be mutually exclusive events if they cannot occur at the same time. So for example, if they have no outcomes in common. So a picture of that would look like this. Event A, event B. Okay, so now over here, I'm going to put an example of something that is not mutually exclusive. Okay, so I'm going to have event A, and then I'm going to actually intersect that with an event B so that there's a space here in common. Okay. And this is this, notice how we have an overlap. Okay, and this is the inclusive OR. Okay, this is the inclusive OR. Where over here, this would be considered the exclusive OR. Because over here, you have no overlaps for this one, this first picture that I drew. Okay, then they say they have other examples here. Determine which events are mutually exclusive, and then they want you to explain your answer, justify your answer. So we have randomly selecting a female student and then also randomly selecting a student who is a junior. So you have to think, could that happen at the same time? Could you pick someone who happens to be a female and a junior, a female junior? And yeah, that could happen. So that we actually have this event going on here. Okay, so this is at the same time, occurring at the same time. So that means that that looks like this picture over here. to our right. So this is these events are not mutually exclusive. So you have the event A being selecting the female student, and then you have the event B, which should be selecting a student who's a junior. And this is considered to be not mutually exclusive because you see this happening where it intersects here. There's an overlap. Okay, so I'm writing this comment here. These events are not mutually exclusive because it is possible to select a female junior. Okay, the next part, randomly selecting a person with type A blood and randomly selecting a person with type O blood. Okay, so I'm going to draw this event here to represent somebody with type O blood. And I'm going to draw this event here, which happens to represent somebody with type A blood. And notice here how we wouldn't have an overlap. There's no overlaps, right? So if somebody has these different blood types, you don't want to accidentally give them you don't want to accidentally give them the wrong blood type, right? You have to make sure what the person's blood type is, right? If you're going to give them some kind of blood transfusion, you have to match their blood types, okay? Um, and incidentally, right, there's some studies going on right now with the COVID-19, and some of the researchers are finding out that it appears that people who have type O blood are a little bit less affected from the virus than someone who has a different type A or AB, different blood type. So they fare a little bit better when they have to overcome the COVID-19. So something about the type O blood seems to help these people overcome it a little bit better. So there's some research that's out about that. So for this particular problem, we would say these events are mutually exclusive, and this is because blood types should not overlap, should not be mixed. Okay, so that you have this picture taking place. Okay, next we have rolling a die and getting an odd number. And then we're also rolling a die and getting a number less than 3. Okay, so for this one, what I'm going to do is list some outcomes. Let me list first the outcomes for rolling an odd number. Okay, so we'd have a die with a side of 1 and then a 3, and then a 5. Okay, so I'm drawing a picture, or you could put the number 1, comma, 3, comma, 5. Okay, and then we had also the outcomes for getting a number less than 3. So I'm going to use n just for a number less than 3. So I'm going to write an inequality for that. So that would be 1, 2, but then that's it, because it's got to be less than 3. It didn't say less than or equal to 3. Okay, and then we want to see if there's any overlaps, and you do notice an overlap right here. Okay, so that means we have this diagram taking place. And you notice how there's an overlap. And so these events are not mutually exclusive. These events are not mutually exclusive. And this is because the side with 1 dot overlaps. Okay, then we have randomly selecting a person who is under 21 of age, and then randomly selecting a person who's over 30 years of age. Okay, so somebody here would represent somebody who's under 21 years of age, but then over here you'd have somebody who's over 30. Yeah, and there is no overlap there. You wouldn't be able to find somebody at the same time who's both under 21 and at the same time over 30. That cannot occur. So that means these events are mutually exclusive. Because these have no overlap among the ages. Okay, second page. They have a couple more examples on this page here. So picking a card from an ordinary deck of cards, and then getting a black card, and also getting a red card. Okay, so if you pick a card, okay, and you get a black card, then you pick another card, right, you get a red card, right? There's no overlap. you in a deck of cards, right? I happen to have a deck here. In a deck of cards, you couldn't pull out a card and get a card that's considered both black and red. It's either one or the other. So if I pull out a card, see, it's either going to be black or red. It cannot be both. Okay? And so that means these are mutually exclusive. Selecting a song on the radio, and the song is it happens to be in the top 40 list, and then the song also happens to be a pop song. So yeah, we could see that happening. We could see that happening, that the song happens to be at the same time a top 40 song and a pop song. So this is not mutually exclusive. Okay, now here we start with some rules for this chapter. We start with something called the addition rule. Okay, so it says when two events A and B are mutually exclusive. So you have this picture here of mutually exclusive. The probability that A or B will occur is this. Probability of A or B is equal to probability of A plus probability of B. And there's no overlap here, okay? And so um, this or can also be treated as a union, okay? When you have an and, then that's treated as a intersection. So that's good to know. And let's see. Yeah, and then, okay. So I'm going to write down an example of a problem that you might have on your homework. And let's see. So let's see. Example. I don't know where to write it here. Guess I will do this. Try it that way. Okay. So example. So suppose they tell you that the probability of event A is 47 hundredths and the probability of event B is 35 hundredths. Okay. And they also tell you that the probability of A union B is equal to, by definition, probability of A or B, which is equal to, let's say they give you the value 82 hundredths. And they want to know, the question is they're asking is, are A and B, are they going to be mutually exclusive? Okay, so in other words, mutually exclusive meaning that, and let me write this over here, um, mutually exclusive, right? Meaning that there's no overlaps, meaning that there's no subtractions needed. Okay, so let's make a note of this. What's going to happen with our algebra here when we do our substitutions? We're going to do our substitutions and we want to see if we're going to get a true statement or a false statement. Does the left side of the equation equal the right side of the equation when we do our substitutions based on these values that they give us? And if we have true results after a substitution reveals the events are mutually exclusive. But if you get false results after a substitution imply not mutually exclusive. Okay, so let's do the substitution. So let's write down that formula. Probability of A union B is equal to probability of A plus probability of B. And let's do our substitutions. Let's substitute our values. So remember they told us that the probability of A union B was 82 hundredths. Okay, I'm going to put a question mark here over the equal sign. And remember they told us the probability of A was 47 hundredths. And they also told us the probability of B was 35 hundredths. Okay, so it turns out when you look on the right hand side and you add 47 hundredths and 35 hundredths, it does give you a value of 82 hundredths. It does give us a true a true result. So that means to answer this question, are A and B mutually exclusive? We could say yes. A and B are considered mutually exclusive. And this is because we obtain a true statement. Okay, so if you need to pause the video, go ahead and do that. But otherwise, if you're able to keep up with the writing, let's go to the next page, 106. Okay, so what I'm going to do at the top of this page is I'm gonna write this rule at the top. This is the rule number one, addition rule. Probability of A or B is equal to probability of A plus probability of B. I'm going to draw these circles, and remember, I'm going to put mutually exclusive. And these two examples on this page are going to be examples demonstrating that mutually exclusive. So when I show my work for it, I will use the definition to support that. So R&D employees, the corporate research and development centers for 3 local companies have the following number of employees. So we have 110 people for the steel company, 750 for the Alcoa, and then the Bayer Material Science has 250. So what I would have to do is I would have to come up with the total. So I do have to use my calculator and add all these up, and that would give me 1,110. And this is going to represent our denominator in our probability when we set up our fraction. So this is also going to represent the total possible outcomes. So if a research employee is selected at random, that's always important that we select them randomly. Find the probability that the employee is employed by US Steel or Alcoa. So I'm going to write that out with a capital P for probability. And I'm going to say employed by US Steel or Alcoa. And basically on the outcomes, I don't need to draw my lines and put my outcomes here because, and I'm talking about like this, I don't have to draw my line and put my outcomes here because technically I do have them right here already listed. Here's the steel and here's the Alcoa. Okay. And so and there would be no overlap. If somebody working at the steel company wouldn't be working at the same time at the Alcoa, there's no information to assume that, okay? And so you wouldn't have anything being circled, anything overlapping in both outcomes. So this is an example that demonstrates addition rule number one. So if I start with the definition, probably of A or B, this is probably of A plus probably of B. So for us, we have the US still plus the Alcoa. Okay. And then I'm going to substitute. So for the still, I have 110 out of 1,110. And then for the Alcoa, I have 750 over 1,110. And then when I add both of these up, add them up, that gives me a total of 860 over 1,110. Okay. And then, you know, I can do a little bit of reduction here. Um, N zeros, you have an N zero at the back here. You would be allowed to technically mark those off. It's like you're dividing by 10, and that would give us 86 over 111. Okay, so this is your fraction. If they insisted on a decimal, you could just divide 86 divided by 111. And if you were unsure about the reduction, you could go to 860 divided by 1110. And you see we get the same decimal. So this is 0.7747747748. And usually they'll have you round off to a place value. Usually it's 3 decimal places, or I'll say thousands. But you would round to whatever they suggest in your Connect Math, which is usually going to be 1,000, tens, hundreds, thousands. Then look at the neighbor to the right. So tens, hundreds, thousands. Look at the neighbor to the right. Is that neighbor 5 or more? Yes, that's a 7 right here. So you have to increase the box digit by 1. So you have 0.775. That would be your decimal equivalency. And then also in this chapter, sometimes they want a fraction. So a fraction would be, if they want a fraction, you could go back to the original 860 over 1110 times 100%. So 860 divided by 1110 and then times 100. That gives you 77.47747748, and then it's a percent. And usually on the percents, they would probably have you round off to nearest tenths, probably. Is what they, either the whole percent or the nearest tenths. If they have you round to nearest tenths, you look at the number to the right. Is that 5 or more? Yes, that's a 7. So you add 1 to the 4. So you have about 77.5%. If they want the nearest whole percent, you box the 7, you look at the number to the right, which is the 4. Is that 5 or more? No. Then it would stay 77%. That's the nearest whole percent. And this is the nearest tenths percent. Okay. So throughout this test, when we get ready to take test 2, we will ask For answers, we never like ask for all of them at the same time. The fraction and the decimal and the percent, never at the same time, all of them. But on throughout your test, you'll be asked for different. Either write it as a fraction, it's expected to be in lowest terms, or write it as a decimal, then we would tell you what place value to round to, or round it to nearest percent. Okay. Okay, and then this is just telling you that um, this is telling you that the rule can be applied, extended, they say, to three or more events. So you see they have an or C, probably A plus probably B plus probably C. Okay. Okay, and just remember if I think if you ever need to increase the screen if something is viewed too small, you can always do a control plus sign. The control plus increases your screen, and then control minus will decrease it back to 100%. So you can, if you ever need to toggle with that on these media sites, you should be able to do that to enlarge the videos. Okay, here's another example of this rule number one. And this is, remember what this is called? This is called the addition, right? Addition rule number one. Okay. So a media rental store rented the following number of movie titles in each of these categories. So you have, we're going to have to add this up on your calculator to get the total for your denominator. So you'd have to add 162 horror, 234 drama, 114 mystery, 312 romance, and 134 comedy. And when you add those all up, you should get 956, and that's going to represent our denominator. And we will assume that there's no overlaps. Um, Back in the day, remember when they used to have blockbusters and what was the other one? Hollywood Video. They don't, those are now obsolete, right? They really don't have those anymore. Um, but they used to have like movies that were in the, they would call them rom-com, like a romantic comedy, a movie that's romantic and comedy at the same time, rom-com. We just won't assume that here, although some of those overlaps can occur. You know, back in the day when we had those type of stores and they would classify them. It's just here because they're not telling that kind of information, revealing that here, we would just assume there's no overlap there. And so this falls under like the first example that we did with the still and the Alcoa. So they want to find the probability of the movie that you select would be um, a horror movie or a comedy movie. And so again, when we use our definition, we would say probability of horror plus probability of comedy. And then the horror, there's 162, whereas the comedy, there's 134. And you have to put them over the total denominator, which is 956. And then we're assuming there's no overlap. And so there's no need to subtract anything. And so when you add those up, you get 296 over 956. And the decimal equivalency would be 296 divided by 956. Here's your decimal equivalency. 0.3096234431. If I round that to the nearest thousands, tens, hundreds, thousands, I'm boxing the 9. Look at the number to the right. Is that 5 or more? Yep, that's a 6. So add 1 to this. 9 plus 1 is 10. Carry the 1. This is 3. Okay. Okay, so you have this here. Okay, and then if you want your fraction, you would do a math, and then you would do a frac on that, and then enter. And see how you get 74 over 239? Okay. Again, if you needed the percent, you would do times 100. That doesn't look right. So better start from scratch. That would be 296 divided by 956 times 100. Yeah, so it'd be 30.9. If you were rounding to the nearest tens, this is neighbors 5 or more, you'd add 1 to this. So then it'd be 31%, 31.0%. Okay. Okay, next page. Okay, now we're going to focus on problems that are an example of the addition rule number 2 in this chapter. So here in this picture, you see how this is shaded? See how there's an overlap? So if A and B are not mutually exclusive, then we have probability of A or B is equal to probability of A plus probability of B. But this time you're going to have to subtract the overlap. So here we subtract any overlaps. And this would represent the overlap probably of A and B. This represents the overlap here. So you want to subtract them out because you don't want to count them twice. That's why. Okay. So here's an example of that. Medical staff in a hospital unit. There are 8 nurses and 8 physicians. And we're actually going to need a table here. We're going to need a table. So let me draw this out here. Let me see. So in a hospital unit, there are 8 nurses and 5 physicians. Okay. So you can see from my table the way I've drawn this. And this is not the only way to draw the table. If you wanted to put the nurses and the physicians listed um, in this first column, you could, and then put the female and male across the top here, horizontally across the first row. You could do that also. So you could, these could be swap locations, and that would be okay also to draw it that way. But we're going to put the total. There's 8 nurses and there's 5 physicians. So you see that gives us a total of 13. And that means that that's our denominator. 7 nurses and 3 physicians are females. So if you go to the females, 7 nurses and 3 physicians are females. Okay. So here, 7 and 3 gives us a total of 10. And then we need, and then that's all they tell us as far as the numbers. And then they go on to say that if a staff is selected, randomly selected, find the probability that the subject is a nurse or a male. And you see this uses the or. And so I would have my outcomes for the nurse. This is an or. Then I would have the outcomes for the male. Okay. And then over here, to fill these blanks in, I'm going to use some subtraction. I know the total's 8, and I know I have 7 females. So 8 minus 7, that would just leave me with 1 male. And over here, I know I have a total of 5 physicians, and 3 of them are female. So 5 minus 3 leaves me with 2 that are male. So now across this total for males, 1 plus 2 is 3. And see, this checks off. 10 plus 3 is 13. So sometimes on tests, when people miss things, and I go back, look at their work and their table, why did they miss things? Sometimes they miss it because their denominator is off. So you should take the time to count up and down and horizontally count and make sure those numbers match, and then just be careful, because if one little number is off, that throws everything off in your probability. So the denominator is very important. Okay. And over here, when I list my outcomes for the nurse, I go to my nurse and I have 7 comma 1, and then my total is 8 outcomes. So when I have an or, I do keep track of the totals. When I have an and, I won't keep track. There's not a need to keep track of the totals. But when we have an or, we want to keep track of the totals. And then the outcomes for the male, it's 1 comma 2, and then the total is 3. So 1 comma 2, and then the total is 3 total. Okay, so it's 1, 2 for the male. Okay. And then when I look at the overlaps, see how you see overlap right there? And the overlap is just, it's one overlap, and it's consists of one. So we do have an overlap. So in your picture, we do have this. So you don't want to count somebody twice. So we would take out that overlap. So the remember here's your formula. Remember your formula? Here's your formula. So I'm going to write this out formally for the first time. So we have um, that this is equal to probability of A or B is equal to probability of A plus probability of B, take away probability of A and B. And remember, this is called the inclusive OR. So let me write that over here. This is an example of the inclusive OR. So probability of A would be for us it's probability of the nurses plus probability of the males. And then we're taking away the probability of the nurse and the male. The nurse and the male. Okay. So we have for probability of nurse, that's why I keep these totals. See, there was 8 and the denominator was 13. Okay. You can also see on the nurse over here in the table, you see 8. And then plus we have the probability of the male, and that would be this number right here. See 3 over 13. And you can see that here on your chart, male, 3 out of 13. And then you're subtracting any overlaps if you have any. And we do have this overlap in pink, and the number is just 1 over 13. Now, let's say this number had been 5. Let's say there were 5 and 5. Then you would subtract 5 out of 13 because these are representing people. These are people like males or females, that count of 5. So you have one overlap of 5s, but you don't want to subtract 1 over 13. If you have 5s here, then you would need to just subtract 5. Now, if these were cards, if you had a deck of cards and you had a, a a 5 and a 5 here on the deck of cards, like a red heart, a red 5 heart, and another red 5 card. If it were a card, then you could subtract 1 out of 13 because you're only going to have, one red heart card. So then if you had cards and you had 5s here and they were cards, then you would subtract the 1 over 13. But if they're people, 5 people, you don't want to count those people twice that overlap, counting them twice. So then you have to subtract 5 out of 13. So you do have to get used to that and practice that. Okay. And then on your calculator, well, whenever you add or subtract fractions, you have to find a common denominator. But the good thing is you already have a common denominator here. So we just do 8 plus 3 minus 1, which is 10 over 13. And that cannot be reduced. So on your homework, um, sometimes the tables are drawn and sometimes they're not. So you'll have to be prepared to sometimes draw up your own table, like I did here on this problem. Okay. And you'll notice you should start printing from your module, your next module on test number 2 material for chapter 4, you should already print your practice test and go ahead and print your template. Those are available for you. That way, when you do your homework, you can also take a look at your practice test and then your template, what's going to be tested, and you'll see on your template, like you should see these type of lines drawn out. You don't want to skip that. Those count as rubric points. So you see on your template what the points are worth, right? So um, you want to keep track of your templates and your point value. So sure, the computer helps me use circle if it's most of the time it's multiple choice. Sometimes there's a few open-ended that you have to type in, but for the most part it's some type of multiple choice. But in order to get the full credit, you have to show your work. If you don't, the rubric shows like these are worth points for your vocabulary and your substitution, and if you don't have that, then you need to your work to support your answer choices for full credit. Okay, so you're responsible for following directions and uploading your work within 15 minutes. Okay. Okay, let's go to the next problem. This is page 108. Okay, so let's see. I see at the bottom there's a problem where it's got the or in it. Down here, there's the or. And we see in this problem that they do have a table. We don't have to make it from scratch. They did provide a table here. Okay. They just didn't put the totals though. So we should go back in and put our totals. Okay, so if I do my total looking at the medical doctor and I just vertically up and down just add these numbers, these counts, that would give me a total of 32. If I add the doctor of osteopathy, add these numbers up, that would give me a 6. Then I could add at the bottom these totals, 32 plus 6 would give me 38. And that would be our denominator for both these problems that are on this page here related to this table. Then I just double check, go across horizontally. Pathology, 10 plus 1 is 11. 5 plus 2 is 7. 17 plus 3 is 20. And then if I were to add these totals here, 11 plus 7 plus 20, that would give me a total of 38. Okay, so that should check out. So we're choosing one doctor at random. Find the probability of the following. And it says she's an orthopedist. Okay. So if I look at the um, orthopedist here, notice how the orthopedist consists of these 17 that are medical doctors, as well as the doctor of osteopathy. So on my formula, this would be probably of the MD plus probably of the osteopathy So probably of the MD would be 17 out of 38, plus probably of the osteopathy would be 3 out of 38. And then 17 plus 3 is 20 over 38. And then this reduces by 2. These are even numbers. Half of 20 is 10. Half of 38 is 19. Okay. So I'm going to just put a note here that when I got this fraction for the 3 out of 38, what you're doing is you're looking at where the orthopedics and the osteopathy intersect. So I looked at where the orthopedics and the osteopathy intersected. It gave me 3. And for the 17 out of 38, what we looked at is we looked at orthopedics and MD intersection. So when we got this 17, we looked at the orthopedics and the MD intersection, which was the 17. Okay. And so our total is 10 over 19 for our probability, right? Our probability. Okay. So then also you can see here in osteopathy, you see this 20 there. So I'm using my vocabulary, I'm using my definition. And this one doesn't have an overlap. Okay. This one doesn't have an overlap. But I think down here at the bottom, when we do this problem with the or, let's see what happens here. So I'm going to put the outcomes for the pediatrician. And then it's an or, and then I put the outcomes for the MD. Okay, so for the pediatrician, let's look at the pediatrician. Pediatrician, I'm going to record 5, comma 2, and I'm also going to put a colon, and the total is 7. 7 total. So remember, we do this for the or. If this had been an and, we wouldn't keep track of this. But since it's an or, we do. And then the outcomes for the medical doctor are 10, 5, and 17. And the total is 32. And when I look at what gets overlapped, like if any intersection, there is an intersection right here of 5. You don't want to count those doctors. These are people. You want to count them twice. So you are going to have to subtract. Okay. So this is an or. And so what we're going to want to do, and we have an overlap. So what you're going to want to do is you're going to want to add the total outcomes, and then you're going to subtract any overlaps. Okay. So this is an example of, let me put this here. This is an example of the addition rule number 2. So this is equal to probability of A plus probability of B probably of A plus probably of B, and then you're going to subtract any overlaps, probably of A and B. Okay, so we have probably of the pediatrician, and the probably the pediatrician, see, is 7 over the total, remember, which was 38. Remember your denominator? So 7 over 38 plus the probability of the MD, which is 32 over 38. So remember the denominator is 38. And then you're going to subtract the overlap. So the probability of the pediatrician and the MD. And that's this overlap here. So you're going to subtract a 5 out of 38. So you're not going to do one. It's one overlap, but you don't do 1 over 38 because these are people. These are people. It's not like it's a card with a 5 on it. These are people. So it's 5 over 38 that you subtract. So then when you get your calculator, you have 7 plus 32, take away 5, which is 34 over 38. And that reduces by 2, half of 34 and half of 38. Okay, so you just do 34 divided by 2, 38 divided by 2. Or you can do the math frac, and that would be fine. Now, if we were to change this problem to an and, if we were to do this problem overs, and if we were to do the and, let me go to the top. So if we were to find the probability of the pediatrician and the MD, and this time it's an and. So what happens on the and is you just sum the overlaps. And so for us, we would have this overlap, one overlap of just 5, and these are people. So this would just be 5 out of the denominator, which is 38. Okay. Now, if you had like 2 circles, like let's say you had 5, and then let's say you had also 10. Let's say you had a 10 here, and then you also have a 10. Then you would have 5 over 38 plus 10 over 38. Okay, if you had another overlap, you would just say plus, and you'd have 10 over 38. If you had 10s overlapping, if you had a 10 here, and you would overlap that. Okay. Okay. So let's see. So in your workbook, this is 109. We'll do this, but then also um, in your module, I do have in your module these extra handouts for 4.2 that I'm going to do these extra problems for practice. And these are good because see how it's got complements. So the workbook was a little deficient because there aren't any, I didn't see any complements in the workbook. That's why I had to kind of make these sheets for extra practice. Okay. Same thing with 4.3. When we do 4.3, I also have um some extra handouts. It says extra on the PDF in your module. It says like 4.2 extra and then 4.3 extra. Okay. Okay, now here you have this table and you see here they did put in the totals for us so we don't have to find them. Okay. And the first problem says they want you to find the probability that it is threatened and in the United States. So I'm going to just do this, do probability and do this, put parentheses there. Okay. And oh, I see that here. Now they have it there. Okay. And then they just have the answer. There's no work. Okay. So it says here that from the table there are 62 species that are threatened and in the United States. Okay, so we look at threatened and in the United States, and that's where they're getting that from here 62. And a total of 802 endangered or threatened species. So they're looking at this total here. So this is like our denominator right here. Hence, the probability of picking a species that is threatened in the United States is this. So what they're doing is when they're calculating this, this is equal to technically under threatened and US, it's 11 over the denominator 802 plus 16 over the denominator plus 27 over the denominator plus 8 over the denominator. So I'm actually going to write it up this way. And so when you add all these numerators, that gives you the 62 out of 802. And then when you use your calculator for that, 62 divided by 82. And it looks like they're rounding to the nearest thousands. Tenths, hundreds, thousands. You look at the number to the right. Is that 5 or more? No. So we have, oh, I think I typed my denominator wrong, didn't I? I left out the 0. Let me go back again. Sorry. Oh, there we go. And the only reason why I noticed that is because it wasn't rounding correctly. That's the only reason why I noticed that. So you have to be careful. So you have one little mistake, makes a mistake somewhere. So be careful. Tens, hundreds, thousands. Look at the number to the right. Is that 5 or more? No, it's a 3. So no need to increase this. So then it stays a 7. So 0.077. And that matches what they have there. Okay. And the other thing I was going to mention is that this is not a true and. This is not an and where you would want to just sum the overlaps. And the reason why this is not a true and is because for this to be a true and, you would have to um, look at a heading across the horizontal part of your chart here, and then you would have to intersect that, like the length and the width. You would have to get a heading from your length and then and intersect it with a heading from your width. So like if they had said, threaten US threaten and a mammal, then that would be a true and. Then I would have written out the outcomes for the threatened US and then another list of outcomes for the mammals. Okay. But this is not intersecting in that way. This is just threatened and United States. This is in the same within the same horizontal heading, the same length heading. So this is not a true and. So I am going to just write that up. This is not a true and because the subjects are found along the same dimension, namely the length only. So it's not like you're grabbing from the length and you're grabbing from the width. It's just the length only. So it's not a true and. Okay, next we have find the probability of an endangered foreign bird. So probably endangered foreign bird. So it says that from the table there are 184 species that are an endangered foreign bird. Okay, let's make sure of that. Endangered foreign, and then bird. Endangered foreign and then bird. Yep, 184. Okay, but that's all. That's all. We don't have a and some other subject or an or another subject. It's just that. And then the total is 802, and so you grab that from your denominator. Endangered or threatened species. Hence, probably a picking a species that is an endangered foreign bird is this. So they're getting that from 184 over 802. So when I do 184 divided by 802, tens, hundreds, thousands. And look at the number. Is that 5 or more? No. So we have 229. And that matches what they got there. Okay. All right. So like on the test and your work, you would just like here I guess this is showing your work here. Here this is showing your work how you got that, right? Okay, next. Okay, here looks like we have an or. Let's see if it's a true or. So we have a mammal, and we have a probability that you have a mammal or a threatened foreign species. So the mammal comes from here, or a threatened foreign species. Yeah. So you see, you're taking from both dimensions, the width and the length. Yeah. So this is you got those subjects. This is an or. So this is one where on like on a test, I'll have here the mammal outcomes, and this is an or. And then I have the threatened foreign species. So yeah, they're subjects. So there's these are not people, right? These are species. No, so not a person. Threatened foreign. These are your subjects. Okay, now for the and it's an or, so I keep track of the totals. So for the mammal, I have 71, comma 257, comma 11, comma 23, comma, and then my total I do keep track of because it's an or 362. So I'm going to write those down. Okay, now for the threatened foreign species, threatened foreign, I have all these 23, 4, 17, 5, and then the total is 49. Okay, now when I look for any overlaps, notice how you have the overlap right here, the 23. See that? You have one overlap, so you have an overlap. So you need to make sure you subtract the overlap to not count them twice. So you do need to subtract them. So you start by adding all your outcomes. So you see 362 over the denominator. See, the denominator is 802. So you see that's this right here. 362 over 802 plus, see, 49 over 802. And then you see, take away 23. See, take away the overlaps. Okay, so then that gives you 362 plus the 49. And then you take away the overlap. And see, you don't take away one, you take away 23 because these are species. They're not people, but they're species. It's not like if it were a card, well, there is no card that has 23, but if it was like a marble that had 23 on it, then you minus one over that. But this is species, so minus 23. And then we have 388 over the denominator. Okay, and then when I do 388 divided by 802, tens, hundreds, thousands. Look at the neighbor to the right. Is that 5 or more? Yes. So about 0.484 because this is 5 or more, so you increase this. And if let me just do math frac. These are even numbers. So I know this is reducible by 2. So let me just for the practice do a math, and then the frac. So hit the enter down here, the enter, and then hit enter again. Hit enter again, and that does reduce to 194 over 401. Okay, that's if you wanted that as a fraction in lowest terms. Okay, so now I'm going to do my extra handouts. I am going to remind you, if you haven't printed this out yet, you need to print this sheet out. And this is in your module for test 2. This is in color here, has the cards red, black. This has the sample space when you're rolling two die, the sample space for that, right? So 2, 3, that's this one right here. First die lands on the 2, second one lies on the 3, 2, 3. So that's your sample space for rolling 2 die. This will be used for quiz 3. This will be used for test 3, and I believe we can use it for quiz 3. So I just wanted to save paper, so I put that all on the same sheet. But you're going to basic using this for test 2, chapter 4, probability. So you need to print that out if you haven't done so already. And then let's take a look at these are extras. These 3 extra sheets, there's 3 of them. Okay, so we're going to do these extra problems for practice. Okay, so you want to take a break? You can take a break. I'm going to keep going before I get sleepy. Let me hurry up and finish this because I'm on this. You know what happens when I apologize in the past if I've dozed off? So I get tired. I have to record myself trying to do it when everybody goes to sleep at home. Oh, goodness. Okay, here we go. I need to make sure I save my videos on some kind of a YouTube. I don't have to record these again to salvage my videos. So I need to get some training to get those saved. Look into that. Okay, here we go. So at a used book sale, 108 books are adult books. Okay, so adult books, 108. And 165 are children's books. So children's books, 165. And if I add this and this on my calculator, that gives me 273. And this is going to be our denominator. Of the adult books, 78 are nonfiction. So the adult books, 78 are nonfiction, while 70 of the children's books are nonfiction. Okay. And then that's all the numbers they give us. And then they start telling us to find these probabilities. Okay. And the thing is that, we need to fill all this in. We're going to use subtraction, like to get this number. The total is 108 minus 78. That would give us 30. And then this one's 165. Take away 70. And then that would give us a total of 95. And then if I add both of these up, that gives me 125. And if I add both of these up, that gives me 148. And then I should check if I add these up, you should check on your calculator. That should give you 273. So you want to make sure that you don't have an error here. That's why you should double check those to make sure you don't have an error. And the probability for it being fiction would be fiction. So you have the probability of the adult books, which is 30 over 273. Plus you have the probability of children's books, That's 95 out of 273. And when you add the 30 and the 95, that gives you 125 over 273. And that couldn't be reduced. You can look at that. That couldn't be reduced. Okay. And I won't make it a decimal and a percent. I'll just leave it at that. Now this is interesting. This has a not, probably not a children's nonfiction book. This is a complement. So this we learned in 4.1, probably of E bar. See that? Because of the not. Remember that? Okay, then remember the definition? 1 minus probability of E. Remember that? So now this is 1 minus the probability. And then you rewrite this, but instead of saying that it's not, you say that it is. It is a children's nonfiction book because it's missing the bar. So it is. And then the probably for that it's a children's nonfiction book. Children's nonfiction book 70. 70 over 273. And then whenever you add subtract fractions, you have to have a common denominator. So 273 over 273 minus 70 over 273. And 273 minus 70 is 203. And that actually can be reduced if you do the math frac on that. 29 over 39. So that can be reduced. We do 203 divided by 273. Here's your decimal. Then you hit math, and then you hit frac. Math, and then you want that frac, so you hit enter, and then you hit enter again. And then it gives you the 29 over 39. Okay, so math, enter, and then enter, and that gives that to you. Okay. Okay, here's an or. Here's an or. And you see, to save time on this worksheet, I was trying to save time in class, right? So adult books or children's nonfiction books. So the adult books, 78, comma 30, and then the total is 108. And then the children's nonfiction books, children's nonfiction books is just a 70, just a 70. Okay. And notice how there's no overlap. No overlap. Okay. So remember, if there's no overlap, that's this mutually exclusive. Mutually exclusive. So if there's no overlaps, that means that there's no subtractions needed. Okay. So all you do is you just sum the total outcomes. Okay, so we have, so here's, here's this, probably adults or children's books. So we have probably of the adult books, which is, see, 108, 108 over denominator 273 plus probably of the children's nonfiction books. And that was just a 70. That's the total. So 70. So here I added these, that's 108. Here it's just 70. Okay. But then that's it. There's nothing to subtract. There's no overlap. So there's no adult and children's books. There's no intersection. So when I add those up, this gives me 178 over 273. And as a decimal, this is my decimal. Tens, hundreds, thousands. And look at the number to the right. Is that 5 or more? No. No. So we have, okay, and let me just see if that fraction can be reduced. If I do math frac, math, and then enter to see. Now see, I get the same thing back. Okay. Yeah, so I don't think that can be reduced. Okay. Okay, licensed drivers in the United States. In a recent year, there were the following numbers in thousands of drivers in the United States. So you have males and females, and you have those that are really young. They're 19 or younger. Okay. And then we have 20-year olds and 21-year olds. Okay. So we're going to have to add the total. See, I have the total here. And this is what I'll do on the test to save time. I'll have, see how I have some of the totals? I'll have some of the totals filled in to save a little bit of time on the test, and then you would fill out the rest of the totals. And let me see. Okay, so technically you would get a calculator and add those up. So I'm gonna just reveal what those are. So that should be 8,050, and then here you will have to add across this way. This gives you 3,178. Then you'd have to add up these. That'll give you a grand total of 15,747. And this would be our denominator. And then it says find the probability that they're a male and a 19-year-old or under. So here's your N. So the male and the 19-year-old and under. So I think this is how I typed it in the books. I think there's a little typo in the book because it has or and this has and, but this is just, this is, it goes together. It does go together. Okay. So the main thing is you have the male from this subject from here, horizontal, and then the subject from here. So we're looking at this intersection. So that's going to be, um, it's an and. So I need to do my outcomes. So let me do all my outcomes for the male. For the male, I have these, and I don't have to do the total for the and. I don't do the total. That's only if I have an or. So I just have these numbers, this, comma, this, comma, this. Okay, and now I have the 19-year-olds are under. So I have this, comma, this, and that's it. I don't need this. I don't need that total. It's not an or. And then you want to see if you see any overlaps. And we do see the overlap there, but that's it. That's it. Um, and with the and, all you do for the and is you just sum the overlaps. So it's just this. So this would be 4,746 over the denominator, 15,747. Okay. Okay. And then as a decimal, 4746 divided by 15,747. So tens, hundreds, thousands. Look at the number to the right. Is that 5 or more? Nope. 0.301. And let me just see if this can be reduced again. Let me do math and then frac and hit enter. Then hit enter again. And it did reduce to 1582 divided by 5,249. It's lowest terms. Okay, next find the probability that at least 20 years old. At least 20 means the driver is X is 20 years or older. So that means 20 years or older. So we need age 20 or older. So this is males and females. So we're looking at this total and this total, right? 20 and 21. We're looking at this and this. Okay. So this would be 20-year-old is 3,178 over 15,747. And then 20 or older, 3,306 over 15,747. And so when you add these up, that gives you a total of 6,484 over 15,747. Okay. And then when you use your calculator and you make it a decimal, that should give you this. If you round to your thousands, tens, hundreds, thousands. Look at the neighbors at 5 or more. Yes. So add 1 to that. 4, 1, 2. And if you wanted to make it a fraction, just to practice the fraction would be 6484 over 15,747 times 100%. And hit enter. That'll be 41.17609,703%. And if you round that to the nearest tenths, is the neighbor 5 or more? Yes, it is. It's a 7. So you're going to have to add 1 to that. So we're looking at 41.2%. That's if you round it to nearest tenths. Okay, here it's a medical patient, so a recent study of 300 patients. Okay, so that's her total in this chart here. That's this right here. That's her denominator. 100 alcoholic patients. So alcoholic, so we're going to do here 100. 87 had elevated cholesterol levels. So 87. Okay. And of the 200 non-alcoholic patients, so non-alcoholic patients, there's 200. 43 had elevated cholesterol levels. Okay, it's elevated. If a patient selected at random, find the probability the patient is a non-alcoholic with non-elevated cholesterol levels. So non-alcoholic with non-elevated cholesterol levels. So we need this number right here. We need that number that reflects this. So I'll have to do some calculations, right? So this would be 200 take away 43, which is 157. And if you wanted to complete the table, this cell right here would be 100 minus 87, which is 13. And if you add 13 and 157, that gives you 170. If you add 87 and 43, that gives you 130. And then to check, 130 plus 170 should give you 300. And then going back to our probability that we have non-alcoholic with non-elevated levels, we're looking at this right here. 157 over the total, which is 300. And I believe that cannot be reduced again. Okay, I think that can be reduced. Okay, last page. selecting a card. If one card is drawn from an ordinary deck of cards, find the probability that you have a king or a queen or a diamond. So this one's got the or, and we haven't seen one like this, right? That's got three of them. So we kind of saw that. Let's see, one of the formulas. Let's see. Kind of, saw that idea here that could be applied. There's or, but this example here didn't have any subtractions, no overlaps. So I think when we do this problem, though, we're going to have uh, addition rule number 2. I believe we're going to have something to subtract. Addition rows is to make sure. So and with this or you would sum the events, the outcomes, and then you would subtract any overlapping events if you have them. And this is supposed to be an example of an inclusive or, so we should have some kind of an overlap. The only thing I need to let you know in advance is that the overlaps, they don't need to be among the three events, but just among any two. So when you're going to look for an overlap, it's okay for it to occur among any two. So if I go back to my sample space and I look at my outcomes for the king events, you have the heart and then the diamond and then the spade and then the club. And then when we look at the queen events, heart, diamond, spade, and club. And then you have the diamond events. So the diamonds, you have all those diamonds. And I don't see any that have numbers here. See, these don't have numbers. So I'm going to decrease some of my writing and I'm going to group this and say 2 through 9 for those diamonds. So I have the A's and then I have 2 through 10. And I'm going to keep track of the total. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 of them. So I put a little 9 here. And then I have the face. These are the face cards. And then I'm going to start looking for overlaps. And you notice that the king of diamonds has an overlap. And then you also notice the queen of diamonds has an overlap. See that? 2 of them. Okay, so we do have overlap. So you're going to have to sum the events outcomes. So I'm going to go back and do a total. This one has 4 total. 1, 2, 3, 4. This one has 1, 2, 3, 4. This one, remember, this is 9. See, these are 9. 9, 10, 11, 12, 13. Yeah, because that's the whole suit. a suit has 13 times 4, there's 52 cards. 13 in a suit. Okay, so then you have to sum the outcome. So you're going to have 4 out of 52 because there's 52 cards in a deck of cards, right? 52 cards in a deck of cards plus this one, 4 out of 52 plus this one, 13 out of 52. Okay, but then you're going to have to um, subtract the overlap. So you want to count them twice. So you have this overlap, see, card with a king, so minus 1 over 52. But you also have to subtract this one, 1 over 52. Okay. And even if these cards had been like a 5, like a 5 on them, you know, um, then you would still subtract, right, 1. If you have one card with a 5 that you're referring to, you would do still be minus 1 over 52. It's not like it's 5 species or 5 people. Okay, it's just a card with a 5 on that. Okay. Um, and so when I get my calculator and I have 4 plus 4 plus 13 minus 1, that's a total of 19. 19 out of 52. And that can't be reduced. Okay, rolling a die. So it looks like you're rolling 2 dice. Find the probability of getting a sum greater than 9, or, there's your or, less than 4. Okay, so you would have to, on your cards, back to your handout, you got to use this. Okay, so rolling a sum greater than 9. Greater than 9. Okay, so I'm going to add these up. And you want to look for sums greater than 9. That's 2. That's 3, 4. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. 2 plus 6 is 8. 3 plus 1 is 4. This is 5. This is 6. This is 7. This is 8. This is 9. It wants greater than 9. I didn't say greater than or equal to, so I got to keep going. 5, 6, 7. That's 8, 9. Okay, here we go. 4 and 6 is 10. So that's our first one. Greater than 9. Okay, next. 6, 7, 8, 9. Here's another one. 5 and 5 is 10. 5 and 6 is 11. This totals 7, 8, 9. 6 and 4, which is different from 4 and 6 because this is the first die. Here, the first die lands on a 4. Second one lands on a 6. But then here, this one, the first die lands on a 6. And then this one lands on a 4. Okay, these are different. Okay. right, so then, so 6 and 4, 6 and 5, 6 and 6. So this has a total of 1, 2, 3, 4, 5, 6. Because this is an or. We don't do that for the and, but for the ors we do. And then rolling a sum less than 4, less than 4. So that's less than 4. That's only 2. That's less than 4. That's 3. That's equal to 4. That's equal to 4. You went less than 4. That's too big. That's 5. 6. That's too big. 7. Too big. Less than 4. 2 plus 1 is 3. 2 plus 2 is 4. You went less than 4. 2 plus 3 is 5. Yes, too big. Okay, so these are our results. Okay, and then see, do you see any overlaps? Let's see, do you see anything? 1, 1. I don't see 1, 1 up here. How about 1, 2? I don't see 1, 2 here. How about 2, 1? Nope. So this one has no overlaps. So there's nothing to subtract. Okay. No overlaps, no subtraction needed. Just sum the outcomes. This is called the exclusive or. Okay. Okay. So then we have where did I put the probability? Oh, over here. Over here. So I have 6 out of 52 because there's 52 cards in a deck of cards. Plus this one had 3. 1, 2, 3. So 3 out of 52. And then there's nothing to subtract. There's no overlaps, nothing to subtract. So this just gives me 9 over 52. And that can be reduced over. Oh, I'm sorry. It's not over 52. Oh, it's not over 50. That's for cards. Sorry, that's for cards. This is sorry. This is um this cards are 52, but we're here. This is 36. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 6, 36. This is 36. This is a denominator. 36, not 52. Sorry about that. And then that reduces by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. Okay. And then 1 divided by 4 is 0.25. And 1/4 times 100%. 1 divided by 4 times 100 is 25%. Okay, now it says, now suppose that probably that you roll doubles or a sum of 7 is 1/3, which is about 0.33, round it to the hundreds place. Then which is least likely to occur? This event or or this event where we got 0.25 or 25%. So on this, think about, you'd have to talk about this. You have 0, 1. This is impossible. This is certain. This is also 0%. This is 100%. And then here you have the 0 0.5, 50%. So you're at the 50, 50 chance. Okay. And remember, if you land in this area, this is likely to occur. If you land in this area here, you're unlikely to occur. And we have these two percentages. We have the 0.25 and the 0.33. 0.25 and the 0.33. So I think that would be, let's see, this is like halfway in between 0.25 and then 0.33 would be about, maybe about right here. So the one that's least likely to occur would be this one, the 0.25. The probability of getting a sum greater than 9 or less than 4. This one's least likely to occur because this one is closer to 0, closer to 0. So the probability of a sum greater than 9 or less than 4 is least likely to occur. And the reason why is because it's closer to 0. So least likely occur means which one's, you know, unlikely, and least like unlikely, which one's closer to 0. Okay, so the 0.25 is closer. And that reflects the probability of a sum greater than 9 or less than 4. Okay, that concludes this section. So please complete your homework, and complete your homework for understanding, and of course completion and understanding. So when you do your homework, practice your homework like this, showing your work. That way you're not just doing it for the first time on a test. So that's why we don't give you a whole lot of homework. So it's doable, and we want you to practice showing your work, and then you check your answer in the computer. That way when you take the test, you've been practicing that, and you won't be so rusty on the day of the test. Okay? Good luck with that. Again, let me put a plug in for Math Row. After you watch the Zoom videos in their entirety, if you still have questions, and please make use of our campus math row where you join the Zoom link. I would recommend Trudy. She's our go-to person. And the person who works in the evening, I believe it's Deborah. And so go to in your Canvas course, you have a math row module where the links are there. So again, I would recommend Trudy is the go-to person because she has been trained. She has been paid to sit in the instructor's classes and to listen to the lecture and to see how this is work is needs to be done. And so she knows about how we make use of the calculator. Deborah may not be aware of that. And so Deborah might try to do it by hand, like the way some of your Connect Math videos, they do things a long way by hand, but we are, for the most part, allowed to use our calculators, like with the commands. And so you just might need to reminder of that. But we still show our work, right? We still do our substitutions and we write the formula and the variable down. But you just might want to reminder Deborah about that. But Trudy knows about that because she sat in the classes. Okay. Okay. So good luck with that.